AI application in mining. AI applications in mining. Beginner level. Introduction. AI in mining refers to using artificial intelligence to improve the exploration, extraction, and processing of natural resources such as coal, gold, iron ore, copper, minerals. Mining is a complex and risky industry involving heavy machinery, harsh environments, safety hazards, large-scale operations. AI helps make mining operations safer, more efficient, cost-effective, automated. Examples of AI in mining include predictive maintenance of equipment, autonomous mining vehicles, ore detection and analysis, safety monitoring systems, resource optimization. This topic helps beginners understand how AI is used in industrial environments. What is AI in mining? AI in mining is the use of intelligent systems to optimize mining operations. In simple words, AI in mining equals using smart systems to extract minerals safely and efficiently. A beginner-level system includes resource detection, equipment monitoring, safety systems, automation, data analysis. Why AI in mining is important. Mining faces challenges such as dangerous working conditions, equipment failures, high operational costs, environmental impact. AI helps by checkmark improving safety, checkmark reducing downtime, checkmark optimizing resource extraction, checkmark lowering costs, checkmark increasing productivity. Key features of AI in mining. Feature purpose. Predictive maintenance prevent machine failures. Autonomous vehicles automate mining operations. Ore detection identify valuable minerals. Safety monitoring detect hazards. Resource optimization improve extraction efficiency. Example mining data. AI systems use data like mining_data equals equipment_status, active, temperature, 85, vibration, high, ore_quality, medium, closing curly bracket. Simple equipment monitoring example. Temperature equals 90. If temperature greater than 80. Print. Warning. Overheating detected. Else. Print. Equipment normal. How AI in mining works. Step 1. Collect data. AI collects data from sensors on machines, cameras, geological surveys, environmental monitoring systems. Example. Temperature equals 75. Vibration equals normal. Step 2. Analyze conditions. AI analyzes machine and environmental data. Example. If vibration equals high. Print. Possible machine issue. Step 3. Detect problems or opportunities. AI identifies risks or valuable resources. Example. If temperature greater than 85. Print. Machine overheating. Step 4. Take action. AI can alert operators, stop machines, optimize processes. Example. Risk equals true. If risk. Print. Shut down machine. AI in predictive maintenance. Prevents equipment failures. Vibration equals high. If vibration equals high. Print. Schedule maintenance. AI in autonomous vehicles. Controls mining trucks and machines. Obstacle equals true. If obstacle. Print. Stop vehicle. AI in ore detection. Identifies valuable minerals. Ore_quality equals high. If ore_quality equals high. Print. Extract ore. AI in safety monitoring. Detects hazards. Gas_level equals high. If gas_level equals high. Print. Evacuate area. AI in resource optimization. Improves efficiency. Efficiency equals 70. If efficiency less than 80. Print. Optimize process. Full menu-based AI mining system. Python. Def check underscore equipment. Temp equals int. Input. Enter temperature. Quote. If temp greater than 80. Print. Overheating detected. Else. Print. Equipment normal. Def maintenance. Vibration equals input. Vibration level. Low, high. Quote. If vibration equals high. Print. Maintenance required. Else. Print. No maintenance needed. Def or underscore detection. Quality equals input. Or quality. Low, high. Quote. If quality equals high. Print. Proceed with extraction. Else. Print. Low value or. Def safety underscore check. Gas equals input. Gas level. Low, high. Quote. If gas equals high. Print. Evacuate immediately. Else. Print. Safe environment. While true. Print. N1. Check equipment. Print. 2. Maintenance check. Print. 3. Or detection. Print. 4. Safety check. Print. 5. Exit. Choice equals input. Enter choice. Quote. If choice equals 1. Check underscore equipment. L if choice equals 2. Maintenance. L if choice equals 3. Or underscore detection. L if choice equals 4. Safety underscore check. L if choice equals 5. Break. Else. Print. Invalid option. Concepts learned from AI in mining. Checkmark industrial automation. Checkmark predictive maintenance. Checkmark safety systems. Checkmark data-driven decisions. Checkmark resource optimization. Real-life analogy. AI in mining is like a smart operations manager who monitors machines, detects problems early, guides workers safely, finds valuable resources, improves efficiency. Ways to improve this project. You can enhance this project by adding IoT sensor integration, machine learning models, real-time monitoring dashboard, drone-based inspection, computer vision for ore detection, environmental monitoring system. Common mistakes beginners make. Crossmark ignoring safety factors. Crossmark oversimplifying industrial processes. Crossmark not using real sensor data. Crossmark ignoring environmental impact. Crossmark assuming automation replaces all humans. Where AI in mining is used. AI mining systems are used in mining companies, energy industries, geological research, industrial operations, resource extraction companies. Advanced systems include autonomous mining trucks, AI-powered drilling systems, predictive maintenance platforms, environmental monitoring systems. Simple definition. AI in mining. The use of artificial intelligence to improve mining operations, safety, and efficiency. Final summary. AI in mining is a powerful industrial application of AI. It helps beginners learn. Checkmark industrial AI systems. Checkmark automation. Checkmark safety monitoring. Checkmark predictive maintenance. It plays a key role in modern resource extraction and industrial operations.